Alright, welcome to the first lesson of Unit 8. We're going to evaluate definite integrals using our calculator today, and then we're going to apply that ability to solve some AP free response questions. Let's get started. The first thing is to go ahead and reset your calculator just to make sure there's no weird settings on there that might prohibit you from doing any of the following. So to reset your calculator, what you want to do is you want to hit second. That's the blue button in the upper left. Then hit plus, then 7. You're then going to scroll right to all. It's the far right option. You're going to hit 1, and then you're going to hit 2. And that will reset your calculator to all of its original factory settings. Once you've done that, and it might take a minute or two, you're going to make sure you're in classic mode. So you're going to hit mode, that's right next to the second button. You're going to scroll down to the second page, and you're going to see an option that gives you the choice of either classic or math print. Probably it has math print highlighted, and you want to change it to classic. We'll take a look at math print in a second, but make sure you're on classic. And once you've done that, you're ready to go, so let's get started. Okay, so your calculator can evaluate definite integrals. And just remember, of course, that we need to identify the lower limit of integration, the upper limit of integration. We need to define what the function or the integrand is going to be. And we need to make sure we tell it the variable of integration. Okay, so the command to do this is to hit math, that's right here, and then 9. Okay, so go ahead and do that now. Okay, so if you do so, fnint appears with a parentheses here, and here's the order in which you need to feed the information to the calculator. The first thing that you're going to tell it is the function that you want to integrate. So first you're going to give it the integrand, and then you're going to put a comma, and the next thing you need to say is what the variable that you're integrating with respect to. And in almost all cases, we're going to be using x as our variable, so we're going to then input the value x. Okay, and then comma, and you need to make sure you're putting these commas in yourself. Then you're going to tell it the limits of integration. So you're going to start with the lower limit, we'll call that a, whatever that happens to be. That's probably going to be a number, right? And then you're going to need to put a comma, and then the upper limit, b. Okay, so that's the way in which you need to feed the information to your calculator, and you can do this regardless of the integral, and what it will do is actually use a Riemann sum with many subintervals to give you a very accurate approximation. So let's do a quick example here. Let's evaluate the integral from 0 to 2 of x squared dx. And now you can probably evaluate this in your head. The antiderivative of x squared is x cubed over 3. And when you evaluate that at 0, you get 0. So it's simply going to be evaluated at 2, which is 8 over 3. So we know we're expecting an answer of about 2.67. And so let's go ahead and feed this information into our calculator. Try this first on your own, and then go ahead and take a look at how I've written it. Alright, so the first thing I need to give is the function that I'm integrating, and that's going to be x squared, comma, I need to tell it the variable with which I'm integrating with respect to, and that's x. And then I need to input the limits of integration. So that's from 0 to 2. And then I'm going to go ahead and close the parentheses and hit enter. And if I do so, I get 2.6, many sixes, and then a 7, or 2.667 approximately, or 8/3. Notice that your calculator isn't going to return 8/3 because it's going to do an approximation. So it won't give you the exact value as a fraction. It's going to give you the very good approximation. It's the same approximation it would give you if you typed in 8/3 and hit enter into your calculator. Okay, let's go ahead and take quickly a look at what happens if you use math print instead of the classic mode. Alright, let's change from classic mode now to math print. So go back to your mode, scroll down to the second page and select math print instead of classic. Once you've done that, you can try to do the same integration that we just did, except now it'll look slightly different. So let's try it again. Let's go ahead and go to math and then select option 9. And what you'll see should look something like this. And this is very straightforward, right? It just allows you to input your limits of integration, your function, and the variable with which you want to integrate with respect to right into the integration symbol. So it should start off, if you go ahead and make that selection, it should start off with the bottom or the lower limit of integration blinking, and so that's the first thing that you're going to input. So if we are going to evaluate the same definite integral we did previously, our lower limit of integration is going to be 0, so input is 0, and then what you'll do is you'll hit the right arrow and that will move you to the next option. If you ever need to go back, you can hit the left option. And so move right, and that will take you to the upper limit. We'll go to 2. Hit right again, and then that will take you to the function, and so that you're going to input the function that you want to use. And so in this case, we're going to input x squared. Hit right again, that will take you to the variable of integration, and that is going to be x as well. And then you can go ahead and hit enter, and if you do so, you should get a value of 2.667 approximately, and that we know to be right. Alright, so whether you like classic or math print is really up to you. I grew up where the only option was the original fn int option, and they both work equally well and are totally equal as far as what you can do with them in your calculator. So it's really pretty much up to you. Alright, we're going to take a look at one more way that you can evaluate an integral on your calculator, and this involves actually graphing the function and then selecting the integration option while looking at your graph. So let's go ahead and try that now. Okay, let's go ahead and evaluate this definite integral here. Notice that the integrand, this function, is one whose antiderivative we might not be able to readily find. We will learn a technique for integrating this, but at this point we can take advantage of the fact that our calculator can do this quite easily. So I would recommend going ahead and pausing now and trying the strategy that we just went over to evaluate this integral, and then I'm going to show you one more way that we can do it. Okay, so here's how this method is going to work. What we're going to do is graph our function here, t sine t. So go ahead and graph this. You're going to go to y equals, and then you're going to input your function here, and you can use x instead of t. That's perfectly fine, so that should not matter. And make sure that your window is appropriate, so you know that you're going to go between -1 and 2, and then you can adjust your y window appropriately. I would probably start off between -10 and 10 and then shrink it down. And once you do so, your graph should look like this. If you did not get something that looks like this, one thing to check is that your calculator is in radians mode. If it's not, then it won't look like this. But notice that I can go between 0 and 2 in the y value, and that'll give me a nice close up view. So if you recall, we can interpret the value of a definite integral to be the area between the curve and the x-axis that is above the x-axis minus the area that is below. And so here, if we just were able to calculate this area, then we would have the value of the definite integral. And we can do that with the calculate option. So what you want to do is hit second and then the button trace here, and you'll notice that the blue lettering says calc, and that means calculate. So second trace. And then you want to select option 7, so you can hit 7 or scroll down, and you'll notice that that option is the integration option. And then once you hit that, it will give you the option to select a lower limit. So here we want to select a lower limit of -1. So what you'll do is you'll hit negative, remember to use the negative down here, -1, and then press enter. It will then ask you for the upper limit, so hit 2 and then enter. And it might take a second or two, but what you'll see it do is start shading in the area between the curve and the x-axis there, and then it will give you the value of that integral. And so you'll see about 2.042 is the value that it spits out, and that is the value of this definite integral here. Okay, at this point I want you to try a couple of more before you move on to the homework. So go to page 289 in your textbook, and there are 2 more examples. The first example on that page is actually the integral that we just evaluated, and then there are 2 more, so B and C, and that'll just give you a little practice. I would use both the method that we discussed without the graph as well as using the graphical, just so you can play around with it and see which one you like best, which one is fastest, and that way you'll be able to use whichever one you want. Then go ahead and move on to the homework, Unit 8.01 on Math Excel.